Welcome. If you've not yet subscribed, subscribe and make sure you turn on the notification bell so that every time I post a video, you're going to be getting notifications. So here we are going to do this question, which says figure 1.1 is a full-scale drawing of an aluminium bar. So we have this aluminium bar which has these dimensions: 5 centimeters, 2 centimeters, and 2 centimeters for length, height, and width, respectively. So we have this, so this is figure 1.1. The first question says, calculate the volume of the bar. Then B, what other measurements are needed to determine the density of aluminium? C, when placed on a measuring pan, a reading of 56 grams is obtained. On figure 1.2, so this is figure 1.2. On figure 1.2, draw a pointer showing a reading of 56 grams. Then find the density of aluminium bar. So this is the question that we are going to consider. Now, without even wasting time, let us say solutions. For the first part, we know that this is a rectangular aluminium bar, and the way we calculate the volume for a rectangle, volume of this bar, anything having this kind of a shape, the volume is calculated by V is equal to L times B times H, where L is equal to 5 centimeters, B is equal to 2 centimeters, and H is equal to 2 centimeters. So here, when we plug in these values, which are just these, we're going to have 5 centimeters times 2 centimeters times 2 centimeters. So 5 times 2 times 2, 5 times 2 is 10, times 2 it is 20. 20. Then we have centimeter, centimeter, centimeter. So centimeter times centimeter times centimeter, it is centimeter to the third power. So it is, the volume is 20 centimeters or 20 cubic centimeters. 20 cubic centimeters, the units for volume. So this is how the first part should be answered. Then the second part, what other measurements are needed to determine the density of aluminium? So density, we know that density, so let me just erase. So for B, we know that density is equal to mass over volume. And we are just from calculating the volume here. Now the question says, what other measurements are needed to determine the density of aluminium? So what we're just remaining with is M, which is mass. So B, the measurements that are remaining is just mass. And we are done. Then part C, when placed on a measuring pan, a reading of 56 grams is obtained. So on figure 1.2, which is this figure, draw a point showing a reading of 56 grams. So here we just need to draw an arrow which points at 56 mark. So 56 grams. So it is graduated in grams. So here we just need to know. So if this is 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So this is how it is going. And in between, there are 4 graduations or 4 divisions. So we have 1, 2, 3, 4. So from this, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, up to here. So here, since we are looking at 56 mark, we have 50, 51, 52, 53, 54, 55. So 56. So the mark, it is here. So now let me draw an arrow. So here the arrow that is needed is should come right here. So an arrow will be just this one. So on this one, 56. So if this is 55, this is 56, 57, 58, 59, 60. So which is the 0 point. So an arrow should just be drawn like this. And this is how it should be. This one. Now, the last question demands us to find the density. So what is the density of aluminium bar? Now, to find the density, we just need to use the formula since we know that density is equal to mass over volume. So density is equal to mass over volume. Here, the mass that we have is 56 grams and the volume is 20 cubic centimeters. So plugging this in this equation here, we have 56 grams over 20 cubic centimeters. 20 into 56, we are going to get 2.8 grams per cubic centimeter. So this is the density of an aluminium bar. Thank you so much for watching the video, and for this and more, remember to subscribe and turn on the notification bell. Thank you so much.